The first question to ask yourself is, what do I see within the circle? Most people will notice a diameter. The next question becomes, what does a diameter do to a circle? A diameter cuts a circle in half. We call half a circle a semicircle or semicircle. And a semicircle measures 180 degrees within its arc. Therefore, if you look to arc A and the other arc, which measures 95, those two arcs together add up to be 180 degrees. Therefore, to find the measurement of arc A, you would subtract 95 from 180. So 180 minus 95 is equal to 85. The next question you have to ask yourself is, how do I solve for the measurement of angle B? You have to ask yourself, where is the vertex for angle B? The vertex happens to be on the circle, and when the vertex is on the circle, we call that an inscribed angle. When we have an inscribed angle, the formula becomes that the arc is equal to 2 times the angle, and that the angle is equal to the arc divided by 2. So since we're trying to find an angle, we're going to take the arc, which is 95, and divide it by 2 to get angle B. Therefore, 95 divided by 2 is equal to 47.5. The next question is, how do I solve for angle C? Again, notice the diameter in the middle of the circle. The diameter cuts the circle in half. If you look at angle C is an inscribed angle because its vertex lies on the circle. Therefore, there's a semicircle within this made by the diameter. Again, a diameter cuts a circle in half, which means that half of it is 180. So 180 is the intercepted arc for angle C. We know that a semicircle measures 180 degrees. So we already know the measurement of the intercepted arc for the inscribed angle C. What we're trying to find is the measurement of angle C. So since we know the arc, in order to find the inscribed angle, it would be 180 divided by 2. 180 divided by 2 equals 90. There are 5 unknown values within this circle that we have to find. The first one that we're going to find is the value of unknown arc measurement E. So to find that, we have to notice that there is a diameter in the circle. That diameter again cuts a circle in half, and you call half a circle a semicircle. And a semicircle measures 180 degrees. Therefore, if you look to the left of the circle, you see that there are 2 arcs on the left side of the circle. You have 120, which is one arc, and you have E, which is the other arc. Again, that arc, the 2 arcs together are a semicircle. They form a semicircle. So if you subtract 120 from 180, you will get the measurement of E, because the total measurement of the semicircle is 180. So if one part is 120, then the other part has to be 60. So 180 minus 120 equals 60. So the measurement of arc E is equal to 60. Next, we're going to find the measurement of arc D. If you look at arc D, it's on the other side of the circle. It's on the right side of the circle. Again, that side is also divided by the diameter, which means that there's a semicircle on that side. So 56 plus D is equal to 180. Another way to do it would be 120 plus the 60 of arc E plus 56 plus D is equal to 360 because there are 360 degrees in a circle. So we subtract 120 plus 60 plus 56, all of that from 360, and we get that D is equal to 124. Next, we're going to find the measurement of angle A. Angle A is an inscribed angle because its vertex lies on the circle. The intercepted arc for angle A is arc E. The first thing that we found was that arc E is equal to 60 degrees. So now that we know what the arc is, we can divide the arc by 2 to get the inscribed angle. 60 divided by 2 is equal to 30. So the measurement of angle A is equal to 30. The next thing that we're going to find is the measurement of angle B. Angle B is an inscribed angle because its vertex lies on the circle. The intercepted arc for angle B measures out at 120 degrees. Therefore, since we know the measurement of the arc, we can divide that measurement by 2 to get the inscribed angle. So 120 divided by 2 is equal to 60. The measurement of angle B is equal to 60. Finally, we're going to find the measurement of angle C. The second thing that we found within this circle was that the measurement of arc D is equal to 120 degrees. Arc D is the intercepted arc for angle C, and angle C is an inscribed angle because its vertex lies on the circle. Therefore, since we know the measurement of arc D, which is 124, we can divide that by 2 to get the inscribed angle. So 124 divided by 2 is equal to 62. Therefore, the measurement of C is equal to 62. This circle has 4 unknown values that we have to find. The first 2 values that we're going to find are the measurements of the angles within the quadrilateral. We're going to find the measurements of angle C and angle D. The first thing that we have to recognize is that we have a quadrilateral written within a circle or inscribed within a circle. And when that happens, the opposite angles within the quadrilateral are equal to 180. They're supplementary. So to find C, we would add C plus 95 and set it equal to 180. So 180 minus 96 will give us C. 180 minus 96 will give us C. And it's 84. To find D, we do something similar. D plus 100 equals 180. So 180 minus 100 will give us D. D equals 80. Next, we're going to find the value of arc A. To find the value of arc A, we have to recognize something. One of the vertices of the quadrilateral that's inscribed within the circle is equal to 100. And that angle has an intercepted arc that includes angle A and it includes 99 degrees. That's something you have to recognize. It's a key to getting this problem correct. So A plus 99 is equal to 2 times 100. Again, we know what the inscribed angle is. The inscribed angle in this case is going to be 100. The intercepted arc for that angle would be the 99 plus the unknown arc A. So those two arcs together all are the intercepted arc. So we have arc A and arc 99 degrees. So we set up our equation as 100 times 2. Again, it's the inscribed angle times 2 is equal to the arc. And the arc is represented by 99 plus A. The rest becomes algebra. So 100 times 2 is 200. Now we subtract 99 from both sides. 200 minus 99 is 101. So A is equal to 101. Finally, we have to find the measure of angle B, or excuse me, arc B. What we have to notice in this case is that arc B is a part of an intercepted arc along with arc A. So arc A plus arc B is equal to the intercepted arc of angle 84, which is C. So to solve this, we're going to multiply 2 times the inscribed angle 84 and set it equal to arc A plus B. Now we just found out that A is equal to 101, so the equation would be 84 times 2 is equal to 101 plus B. The rest becomes algebra. 84 times 2 is 168, excuse me. We subtract 101 from both sides. 168 minus 101 is equal to 67. So arc B is equal to 67. There are 3 unknown values within the circle that we have to find. The first thing that I notice is that there's a vertex in the middle of the circle for an angle, and we call that a central angle because the vertex is at the center point of the circle. That central angle is equal to 44 degrees, and thus the intercepted arc of that angle is also equal to 44 degrees. Another thing to notice is that angle A is an inscribed angle because its vertex is on the circle. The intercepted arc for angle A would be the 44 degrees of the arc. So since we know the measurement of the arc, we can find the measurement of the angle by dividing that arc by 2. So 44 divided by 2 is equal to angle A. 44 divided by 2 is equal to 22. Next, we're going to find the value of arc C. There are 360 degrees in a circle, and we notice that there are 3 arcs within the circle. One of the arcs measures to be 160 degrees, another arc measures to be 44 degrees, and then the third measurement is unknown. So since we know 2 of the measurements, we can find the unknown measurement because we know the total measurement. So C is equal to 360 minus the 160 plus the 44. So C is equal to 156 degrees. Finally, we're going to find the value of inscribed angle B. We know that B is inscribed because its vertex is on the circle. The intercepted arc for angle B is arc C, and we just found the value of arc C to be 156. So since we know the value of the arc, we can divide that by 2 to get the value of the inscribed angle. So 156 divided by 2 is equal to 78. So the value of inscribed angle B is equal to 78 degrees. There are 4 values that we have to find within the circle. The first value that we're going to find is the measurement of arc BC. To do that, one of the things we have to notice is that arc BC is the intercepted arc of angle A, and the value of angle A is given to us as 48 degrees. So since the value of the inscribed angle is given to us, and we know that angle A is inscribed because its vertex lies on the circle, we're going to multiply 48 times 2 to get the measure of arc BC. So the measure of arc BC is 96. 2 times 48 is 96. The next value that we're going to find is the value of angle B. To do that, we have to first recognize that angle B is an inscribed angle because its vertex lies on the circle. Angle B has an intercepted arc of arc AC. That arc has a given value of 110. So since we have the value of the arc, we can just divide the arc by 2 to get the value of the inscribed angle. So B is equal to 110 divided by 2, which is equal to 55. Next, we're going to find the value of angle C. To do that, we're going to use the triangle sum theorem. Since we know that the value of angle B is 55, we can subtract 55 and 48 from 180 to get the value of angle C. And we know this because the triangle sum theorem states that there are 180 degrees within a triangle. So 180 minus the 48 of angle A and the 55 of angle B will give us the measurement of angle C. 48 plus 55 is 103. So 180 minus 103 is equal to 77. Angle C is 77. Finally, we're going to find the value of arc AB. Since we know the value of angle C to be 77, we're going to multiply that inscribed angle times 2 to get the measure of the intercepted arc, which is AB. So 2 times 77 is equal to 154. The measure of arc AB is 154. Here we have a quadrilateral inscribed within a circle. When that happens, opposite angles are supplementary, which means that those angles together add up to be 180 degrees. So to solve for x, we're going to set 4x plus 9 plus 3x plus 3 equal to 180. 4x plus 9 plus 3x plus 3 equals 180. The rest becomes algebra. So we're going to combine like terms. 4x plus 3x gives us 7x, and 9 plus 3 gives us 12. So we have 7x plus 12 is equal to 180. Next, we're going to subtract 12 from both sides. 180 minus 12 equals 168. So 7x equals 168. Finally, we're going to divide both sides by 7. 168 divided by 7 is equal to 24. Therefore, x equals 24. Within this circle, we have two chords that intersect each other. However, they don't intersect each other at the center point of the circle. Therefore, there's an equation that we have to use. That equation is that the first arc plus the second arc, all divided by 2, is equal to the angle that intercepts the 2 arcs. So to solve this, we're going to add 3x plus 3 plus 10x minus 14 and divide all of that by 2 and set it equal to 53. The rest becomes algebra. We multiply 2 to both sides. After simplifying, (53 times 2 is 106). Now we're going to add 11 to both sides. 13x equals 117. Then we divide both sides by 13. And finally, 117 divided by 13 is equal to 9. Next, we're asked to find the value of the arcs. So we're going to substitute 9 into x for both of the arcs. So 3x plus 3, we substitute the 9. 3 times 9 plus 3. 3 times 9 is 27 plus 3. Final answer is 30 for that particular arc. So arc 1 is equal to 30. To find arc 2, we're going to substitute 9 for x. So 10x minus 14 is the expression that we're given. We substitute the 9. 10 times 9 minus 14. 10 times 9 is 90. So 90 minus 14 will give us 76. So the value for the second arc is 76.